Assalamualaikum warahmatullahi wabarakatuh and good morning. So we are done with coordinate geometry. The topic for today is inequalities. You may have covered inequalities in year 7 and 8, but in year 9 there is a little bit more expansion on the topic. Before we begin, let's look at our lesson objectives. So our lesson objectives for today is firstly to recognize and use inequality symbols correctly, to solve linear inequalities and represent the solution on a number line, to find the maximum and minimum values of inequalities within given ranges. Now let's look at the steps to success. So firstly, to recognize and use symbols correctly, to solve linear inequalities and represent solution, and then to find the minimum or maximum values. Okay, I'm not going to go through the mini bullet points on the steps to success because I think it will be easier for you to go through the notes first, then only go back to the steps to success. Okay, let's look at our symbols. We have these symbols here. The first symbol refers to means. The first symbol means strictly greater than. Secondly, strictly less than, and then we have greater than or equal to, and less than or equal to. So I just want to give an example for greater than or equal to, which is this one. Okay, let's say you're going on a ride. It says greater than or equal to 170 centimeter. This means that 170 centimeter is included. So if you're 170 centimeter, you are allowed to go on that ride. But if you're 169, no. But if you're 170, 171, 72, and so on, you are allowed. Okay? So the only difference here is the word equal to. Now, how do we represent equalities on a number line? So let's look at these two number lines first. So firstly, if you have this sort of symbol, you will draw it on the number line with this symbol. So it should be a hollow circle. So this inequality says y1 is greater than 2. So you're going to put a symbol on the number 2, and then since it's greater than, you're going to draw an arrow to this side. This arrow represents that the y1 can be any number greater than 2. So it doesn't just stop here. It can go on and on and on and on and on. Okay? So what's the difference between these two then? So when you look here, it says y2 is greater than or equals to. So the only difference here is the symbol you're using. If the symbol is shaded as follow, then it means that the number 2 is included in the range of y. And then again, it's y2 greater than or equals to 2. So the symbol, the line goes to the right. Okay? Then let's look at this one. What if you have a specific range? You don't have, for the previous example, you have an indefinite range. But what if you have a definite range? So like this, it starts from 2 and it ends at 6. So you will draw the number line, the line on the number line to start from 2 until 6. So you don't have an arrow going that way or an arrow going this way because there is a specific range. In an equality, you may have two different symbols. What I mean by two different symbols is that one symbol may have an equal to sign, but the other symbol may not have. That's simple, just translate it into the equation. So like this, you have an equal to sign. So the symbol here will be a shaded circle. Meanwhile, this one, you don't have an equal to, it's just less than, it's strictly less than. So when you draw it on the number line, it will be a hollow circle. Okay? Next page. How do we solve linear inequalities? Let's look at this first example first. So when you have an equality like this is a simple inequality. It's just 4 plus x is less than 6. So how do you solve for the inequality of x, the range of x? So the same method is applied just like you're solving algebraic linear equations. So you're going to move 4 to the other side so that you are left with x. And then as usual, you're gonna do this operation, which is 6 minus 4, and you get 2. Some question may ask you to stop until here, but there are other questions that may require you to represent it on a number line. Okay, so just draw it like how we have shown you in the previous page. Okay, here's a different example. So for this second example, so the first step is to move 3, which is done normally as you would do in an algebraic equation. Okay, but let's look at this part. When you move -5 to the other side, it will be as if you are dividing it by -5 on this side and -5 on this side. But look, if you put a division on this side of the equation, the symbol will cancel out, which means that x will no longer be greater than. So the symbol will switch. Okay? And then the rest you will do it normally. Okay. So here I put down a note in the notes. It says, when the unknown variable is divided or multiplied by a negative number, the inequality symbol changes. So that's what I was explaining on this part. Let me just repeat that part. So whenever the unknown variable is divided or multiplied by a negative number, which means that here I'm going to divide it by 5, which is a negative number, and I do it on both sides, the inequality symbol changes. So the symbol flips. Okay? Next, finding the maximum or minimum values. Okay, let's look at this example. Given that -3 less than or equals to x is less than or equals to 2, and -7 less than or equals to y is less than or equals to 3, find the largest possible value of x. So you have to sub the value of a value of x and a value of y into this equation to find the largest possible value. So if you want x minus y to be the largest possible value, you have to use the largest value of x and the smallest value of y. So look at this range. What is the largest value of x? So the largest value of x will be 2. So I'm going to put 2 into the equation. And then use the smallest value of y. So you look at the range of y here. What is the smallest value of y? Will be -7. So you sub in -7 into the equation. Then you do the equation normally and you will get the largest possible value of x minus y. Second one, find the largest possible value of x squared. Okay, one thing to note here, any squared number, the answer will always be positive. So if you have -2 squared, it will be 4. It won't be -4, right? So -3 squared, it will be 9. -5 squared will be 25. So if you want the largest possible value of x squared, you look at the range of x, but you don't focus on the negative sign. So you just find what is the largest digit. So the largest digit will be 3, right? So you sub in 3 into the x squared and you get 9, which is the largest possible value of x squared. So that is all for today. Tomorrow we're going to continue on equalities. On Saturday, we're going to continue with inequalities, and I will give you an exercise to practice on equalities. Right? Thank you. Bye.